Anyone else struggling to balance coding yourself versus letting AI do it? Most developers view these assistants as a productivity multiplier, but this video reframes them as the primary generator of architectural debt. The stakes are high because over-reliance on generative code without understanding hardware constraints like latency and cost creates fragile systems that fail at scale. Today, we connect that anxiety to hard engineering data showing how speed is becoming your most expensive liability. The industry narrative tells us that AI coding tools make you faster, but a large-scale empirical study of 302,600 AI authored commits across thousands of repositories reveals a different reality. Generative tools are introducing long-term structural issues far more often than functional bugs. In fact, code smells such as poor naming and duplicated logic accounted for nearly 90% of all detected defects in this analysis. This statistic forces us to stop viewing the problem as merely fixing errors and start managing a form of rapid structural decay that mimics concrete being poured too fast without understanding the foundation beneath it. When you accept AI output without scrutiny, you are not just writing code, you are accumulating silent technical debt that compounds over time. The persistence problem is where this trap becomes dangerous for your career. Of the thousands of issues introduced by these tools, 22.7% persist unchanged through subsequent updates. This indicates a pattern where developers prioritize good enough speed over understanding, leaving architectural fragility in place rather than refactoring it away. You might feel productive today because you are shipping features faster, but that velocity is often borrowed from your future self who will have to pay the interest on this debt when the system finally cracks under its own weight. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The risk extends beyond just messy code into a recursive collapse that threatens the very tools we rely on. Research into recursive self-training reveals a feedback loop where AI-generated code floods repositories and gets reused to train future models without human oversight or external validation like compilation checks. In this regime, acceptance scores rise while actual correctness plummets because the models. This is not just about bad code. It is about accelerating the degradation of future tools by feeding them unreviewed, flawed outputs that they will then replicate and amplify. This creates an inheritance flaw where AI models trained on public repositories frequently inherit existing defects rather than solving them, propagating low-probability errors into production environments. For a software engineer or data practitioner, the immediate risk is not just writing bad code, but becoming dependent on tools that obscure underlying system costs like latency and memory usage. When an AI generates efficient-looking logic for high-scale inference without you understanding how it maps to hardware constraints, you inherit the cost burden without knowing how to optimize it. You might be shipping faster, but you are also silently accepting a higher price tag every time your model runs or scales up. The skill erosion here is real and measurable as automation anxiety takes hold of engineering teams. If developers outsource too much logic without validating the why behind their decisions, they lose the ability to debug complex failures when the model hallucinates or generates suboptimal hardware usage patterns. The study highlights that this dependency creates a false sense of security where teams trust outputs that are actually structurally unsound for production environments. You need to shift from letting AI write it to auditing what AI writes, because the value of an engineer in this era is not speed, but the judgment to identify where generative output violates architectural constraints like excessive token usage or unoptimized loops that spike inference costs. Think of your workflow as a construction site, where you are now managing a crew that pours concrete faster than it can cure. The building looks finished immediately, and on paper you have met every deadline. But without understanding the foundation of hardware constraints, the structure will crack under pressure later when traffic increases or requirements change. This is why we must treat AI as a junior drafter rather than an architect. It needs constant review against real-world performance metrics before any line of code touches production. The solution requires adopting an approach of augmented skepticism where you use hardware constraints as your primary checklist. Before accepting any generated snippet, ask yourself how this logic will perform at scale and what the actual latency cost is for every token processed. This turns the AI from a black box into a tool that serves your engineering goals rather than dictating them. By validating the structural integrity of every piece of code you ship, you ensure that your velocity does not come at the expense of long-term stability or financial efficiency in your inference costs. The more you automate logic without understanding these constraints, the faster your system accumulates hidden costs that only surface when scaling becomes critical. This is the core engineering trade-off we must all master, balancing immediate delivery speed with the structural integrity required for sustainable growth. The data shows us clearly where the danger lies, and it gives us a clear path forward to avoid becoming dependent on tools that are actively degrading our systems from the inside out. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.